Hello and welcome to lesson 3.3. Today we're continuing what we did last class where we had graphed using a table of values. Some people call that a t-table or an xy table where we get the inputs and outputs, we graph those points, and we should have the shape of our graph. Last class we did lines and we did x squared graphs, or what are called quadratic functions or quadratic graphs. These give you that U shape like a parabola. Today we're going to continue with that. So there's not really any new, what's the word I need? Not really any new skills you need. We're just going to look at a few new functions. So I will introduce some terminology to you just lightly, not something I will ask you on the test, but if there's just kind of the root of whatever you're doing with no extra numbers, that's called a parent function. So in today's lesson, I'm going to go through three different function types, and the first thing I'll do is do the parent function, and then I'll do one with a little more pizzazz to it. But you'll see the parent function has the same shape as the other things, but those shapes could be stretched or flipped or shrunk or squished or all sort of fancy things, or turned sideways or spun around. And so this just lets us know kind of what the shape looks like. And a lot of people spend time memorizing a lot of facts about these. As a matter of fact, in 111, you'll have to know a lot about parent functions. I think last class, some of the parent functions we also did, let's see, we did f of x equals x squared, and that was the parabola shape, the U shape. And we did linear, and the simplest form of a linear equation is just equals x, and that gives you a straight line. And we could rotate this, stretch this, tilt this, smush this, flip it, all sort of stuff. Same with both of these. And so that's what we covered last class. This class, like I said, we have a few more that we're going to introduce. So let's get to it. So remember from last class, the way we do this is we make a table of values. We may need a lot of values to get the shape of this graph. And we have our inputs and our outputs. And you can either call this y or, oh, that's a horrible R, you can call this f of x. Whether you want to think of it as a function or just a plain equation, let me erase that because it looks bad. Either of these works. I'm going to put, oh no, that looks like divide. Got to get it together here. Maybe I can write or in a different color and it'll look better. Y or f of x, whichever you want to call it, it doesn't matter. They're all, at this point for us, I'm going to say they're interchangeable. All right, so let's look at this parent function of x to the third. And so if I start picking some values, I'm going to go ahead and just pick -1, or sorry, -2, -1, 0, 1, 2. And that should be enough to kind of start to give us the idea of the shape of this graph. And so if I were to go about my business, plugging in -2, and we're going to do our good technique of making sure we put blank parentheses and then figuring out what do we need to plug in, a -2. Okay, and -2 to the to the third power is -8. I'll be your calculator. You could put these in a calculator, or you could take the time to say, okay, to the third power just means 3 of them. -2 times -2 is +4, and if you multiply another -2, that'd be -8. But that would be like scratch work, or if you didn't have a calculator or couldn't figure out how you wanted to do it. All right, so -8. If we stick a -1 in there, -1 to the third power is -1. I think we could probably do 0 in our heads. If we stick a 0 in there, that would be 0. And at some point, you should get really fast at doing these. Stick a 1 in there. You don't have to show all your work, especially if it's simple. If I stick a 1 in there, 1 to the third power is 1. 2 to the third power is 8. Let's see if that gives us enough of a shape. Okay, so let's see. I got the point -2 in the x direction, -8 in the y direction. Oh, white's not the best thing to use. All right, then I got -1, -1, 0, 0, 1, 1, and 2, 8. So those are the ordered pairs of coordinates that I have, and you end up with a really interesting shape. If I could draw it really well. Oh, okay, I kind of missed it, but it's a squiggle kind of. It's like someone took a straight line and bent it a bit to give us this kind of curvy, kind of S-like shape. Okay, and this can be stretched or squished or flipped or rotated or, you know, all sort of shifted up, down, left, right. But this is the parent function, x to the third, and this is the shape of these x to the third power functions. Okay, you'll learn all about them: domain, range, technical name for what it's called, all this kind of stuff in Math 111. For us, we're just practicing graphing some of them. So let's try one that's not the parent function. Let's try one of these that have more to it. But I know what the shape's going to be like because you see my highest exponent is x to the third. There's no other really weird things going on like absolute values or square roots or anything like that, or fractions, or divided by x's. I have x to the third with some extra stuff. So that's going to give me kind of the same shape, that kind of S-like shape. So we'll just do the same thing, make a table of values or a t-chart or an XY table, whatever you want to call it. And we'll need to pick some values. Now if I pick the same values, let's pick a few of these just for fun. You'll realize that these may not be the best choices anymore. Let me go back for a second. So what I would like to find this point here where the S kind of flips over. Okay, for here it's kind of concave down. Here it's concave up, like a bowl up and a bowl down. I would like to find the point where it flips from curving this way to curving that way and have at least 2 points on each side of it. So for the parent function, that happened at 0, 0. For this function, I have a feeling it's not going to be at 0, 0. But if I were to try that, let's just start with the easiest and plug in 0 because we could do that one in our head. 0 to the third power is 0, plus 2 times 0 is 0, so 0 plus 0 plus 2 is 2. And you can just use a calculator or believe me on these. Alright, now I'm not going to do any others in my head, at least not right now this second. Let's try -2 and -1. So if I plug in -2, what am I going to get? Let's get a different color here. Blank to the third plus 2 blank plus 2. And we are plugging in -2. Let's see, -2 to the third power is -8. 2 times -2 is -4. Plus 2. Oh no, this may not even fit on my graph. That's -12. -8 plus -4 is -12. Plus 2 is -10. So -2, -10. Okay, it does barely fit on my graph. Whew. Okay, that's looking all right. Maybe we will be able to have, maybe these will be good choices. I don't know. Let's keep going here. So let's try f of -1. And so blank to the third plus 2 times blank plus 2. All right, plug it in a -1. -1, so -1 to the third power is -1. Plus 2 times -1 is -2 plus 2. Okay, well plugging in this -1 is going to give us, this would be -3 plus 2 would be -1. -1, -1. Oh, I forgot to write -10 up here. Okay, well that's interesting. Let's plot the other ones I have. Not that I'm spoiling anything. Let's see where to, but just to kind of figure out what's going on here. Whether we have that point or whether we don't. Alright, let's try 1. F of 1. And like I said, this would be all over your place in your scratch work. You could try to be really neat with it, but it's just to spit out these values. Plugging in +1 here. So 1 to the third power is 1. 2 times 1 is 2. Plus 2. So that's going to be 5. The point 1, 5. Okay. Now let's do 2. I may need to shrink some of these things down and get them kind of out of the way. Start sticking them random places to have more space to work here. There we go. Now we have some more space to work. Alright, let's go with, what was I doing? F of 2. Okay, so that's blank to the third power plus 2 blank plus 2. Alright, so if I plug a 2 in here, let's see. This one may not fit on my graph. 2 to the third power is 8. 2 times 2 is 4 plus 2. Oh my, let's see. 8 plus 2 is 8 plus 4 is 12. Plus 2 is 14. That definitely doesn't fit on my graph, but let's try to extend this and try to keep the spacing 11, 12, 13, 14. So 2, 14. Okay, I think I may have the turnaround point. And I think I may have 2 on each side. If I didn't, I would need to go further, and I may would want to start counting by 2s on my graphs or something like that to fit it better and change these points. Ugh. Now, whenever I start giving you other ways of doing this function, so for example, this one ended up being okay with -2, -1, 0, 1, 2. What I wanted to show you with this example is, if this may be a good starting point for these. But if I were to give you one like this, then then these numbers, -1, -2, 0, 1, 2, would not be a good point. You would be far out on one side or the other. Okay, because it all depends on wherever this thing has been shifted to. This one is going to be shifted by 5 left and right, and then up 2. This one did not get shifted left or right at all. The turning point is still right at 0. So that's just something to keep a lookout for. We're not going to give you really hard ones in this class. They're going to be pretty simple. But in Math 111, this thing is going to be shifted around a lot. This one mainly just got moved up and stretched out longer. Okay, based off that parent function. So let's dive into another parent function. Okay, this is just a square root of x. And this one has a special kind of shape. I've seen some teachers call it like a shooting star. It's I don't know, it's just a little kind of weird curve. All right, so same thing, x, y, and we can start thinking of numbers. I want to show you something. Let's just pretend that we use the same numbers as last time, -2, -1, 0, 1, 2, thinking that may be a good idea. But we go to try to figure out f of -2, and oh no. At this point in your mathematical career, now in 111, you'll start figuring out ways to handle this, but we don't know what to do with this. This is not a real number. The square root of, we can't do square roots of negative, so you know what we're going to do? We're just going to say, I'm going to kind of ignore this one. I'm going to leave it alone. Let's leave the negatives off. Anything that makes this inside negative, we don't want to really touch right now. In 111, you'll start dealing with that in complex numbers, or imaginary numbers as some people call them. But we don't do that in 105, and so this is just real numbers for us. We're going to step out of that and say, oh, we can only graph real numbers, and I can't take the square root of a negative. So let's try starting at 0 then. I forgot to write 0 in there. So if I start at 0, that's pretty easy. The square root of 0 is 0. Oof, got it. That was much better than all the negative square roots. Let's try 1. Well, the square root of 1 is 1. Oh man, we're on a roll. Let's try 2. Square root of 2 is, oh, that's a nasty decimal. You know what? We're the one picking these x values. I don't want to graph anything besides whole numbers, so let's not use a 2. Since we're plugging into here, I wonder what would make a perfect square root. You could try 3, but that'd be nasty. You could try 4, and you'd be like, oh, thank goodness, that's a nice one. So let's do f of 4. Square root of 4 is 2. Nice. And we could even do more, and you could try all the numbers. The next one you would hit would be 9, and you'd plug it in, and you'd spit out a 3. Okay? So you could try bunches of numbers. If it's not a nice number, integer that would belong on any of these lattice points, on any of these whole number points, then just not use it. So here we have 0, 0, 1, 1, 4, 2, and 9, 3, and that's all that fits on our graph for this, and you kind of start to see the shape. Now we will talk some about domain and range in our class. You'll have to know all the domain and range stuff for all these parent functions, but for a square root function like this, notice that I could not plug in any negative x's. Okay, we haven't even talked about domain and range yet. We will in this class, don't worry, but I was not allowed any negative x's. They all had to be positive. And notice because of that, because of this function, I didn't get any negative outputs. All of my outputs are positive. I couldn't get any negative outputs. So that's really interesting. It's just kind of like this shape. But if you were to kind of mirror this, you would see it's half of the parabola shape, half of that U shape from an x squared graph. That's interesting. Maybe that makes sense. A square root's kind of the opposite of an x squared. Okay? So if I give you one that's a little more difficult, one like this, and you may try the same things, and you say, it's probably going to start at 0. So let's just start with 0. And you try to start with f of 0. 0 plus 3 minus 4, and you say, oh no, I don't want to do this. That's the square root of 3. That's nasty. I'd rather not. Oh, this probably isn't the starting point then. Okay? The launching point for that graph. So we're going to have to try some x's until we get something good here. And because there's a plus 3 under here, I have a feeling I can actually do some other numbers. So you may have to just try numbers until you get nice ones. I'm going to, because I know, I've done this a lot, I know that negative 3 might work out, because if I put a negative 3 under this square root, negative 3 plus 3 is 0. What else is going to work out? A 1? Actually, a negative 2 would work out too. Let me not skip that one. A negative 2 would work out. 1 would work out. 6 would work out. Let's go with those 4 numbers. Let's get rid of, let's get rid of this stuff. And let's try to work these things out. F of, here I go again right next. I need to wake up some this morning. There we go. F of negative 3. Blank plus 3 all in the square root minus 4 outside the square root. And so we are plugging in negative 3. Well, negative 3 plus 3 is 0. So I have the square root of 0 minus 4. Square root of 0 is 0. So I just have 0 minus 4 or minus 4. So negative 3, negative 4. There I go again, trying to use white. I'm just a mess sometimes. There we go. Trying to get it together. All right, if we do a negative 2 in here, square root of blank plus 3 minus 4. We're plugging in a negative 2. Well, negative 2 plus 3 is 1. And the square root of 1 is 1. And 1 minus 4 is negative 3. Nice. So we have negative 2, negative 3. And then if we do plug a 1 in there, I can do this one for you. I'll be your calculator. So you take the time and plug the 1 in. 1 plus 3 is 4. Square root of 4 is 2. 2 minus 4 is negative 2. Let's make sure that's right. Let's see. 1 plus 3 is 4. Square root of 4 is 2. 2 minus 4 is negative 2. Yep. So we plugged a 1 in and got negative 2. And then if we plug the 6 in, if we plug a 6 in, 6 plus 3 is 9. Square root of 9 is 3. 3 minus 4, 3 minus 4 is negative 1. So 6, negative 1. So here is our shape. Oh, here is our shape this time. Horribly done, but should be a bit more curved. Oh, man. I just keep making it worse. Let me try again. Curve. There we go. That maybe looks better. But you just take your time to plug in your axis. On these last two, I went faster because I can do it in my head. I could be your calculator. But when you're doing it on your own, take the time to make sure you know what these numbers are going to spit out. Okay, one more parent function, then we'll call it a lesson. We'll do 2 more examples then. So here's the parent function of the absolute value of x. That's interesting. I wonder how that one's going to look. Well, I know, and you will soon know, these give you an interesting shape. These will give you a, I don't want to spoil it. Well, I will. Give you a V shape, okay? Because if I were to drop the absolute values, this is just a straight line. That would look like this. But whenever I put the absolute values, it chops all these in the negative off and flips them up to positive, creating a V. Okay, that's a horrible drawing, but it hopefully gives you kind of the idea of what's happening. So let's pick some. Let's just go like negative 5, negative 2, 0, 2, 5. And if I were to take the time to plug these in, it really doesn't matter what numbers you pick. As long as you have some in the negative side and some on the positive side, you will see the shape. And so if I plug a negative, oops, I forgot again to put my negative 5 in there. I'm getting so excited and going so fast. If I plug in a negative 5, I get the absolute value of negative 5. Well, what's the absolute value of negative 5? Positive 5. So we get negative 5, positive 5. If I plug in a negative 2, I think we can probably do these in our heads. The absolute value of negative 2 is positive 2. 0, 0. Positive 2 is positive 2. A 5 is positive 5. So negative 2, 2, 0, 0, 2, 2, and 5, 5. And so you should see our nice V shape here. The things you would like to find out here are where this turnaround point is, where the vertex or the corner of your V is, and then make sure you have at least 2 points on each side of that. It's not always that easy. On a parent function like this, it's 0, 0. That's really simple. But on the next example, this has been slid around a bit. This is going to be steeper or less steep. It's going to be moved over, not from 0, 0. So what we have to do is play with it. You will learn ways of finding the vertex in 111. For us, we're just going to grab some numbers and try some different things. I might put down a lot of numbers. And I may not use all of these, but put down some numbers and we'll try some. So let's start with f of -3. I know the shape because it's an absolute value, and there's no squareds and anything else messing it up. So knowing the shape gives me an advantage. So let's see what -3 gives us. That's -6 plus 1. That would be -5. But the absolute value of -5 is 5, and 5 minus 3 is 2. Okay, let's start putting these on the graph. -3, 2, to see if we can discover where this turnaround is. So we might try -2. Let's see. 2 times -2 is -4 plus 1 minus 3. -4 plus 1 is -3. And -3 is, the absolute value of that is 3. And 3 minus 3 is 0. So we did find 0, but I have a feeling that may not be my vertex. -2, 0. Okay, let's keep going. Let's try -1. I'm going to go ahead and shrink. Oops, didn't mean to do that. Meant to have a mouse. I'm going to go ahead and shrink this down. Control G. Shrink it down so it's not in our way. Maybe we'll just stuff it over there. And let's try that one. What was it? F of -1. All right. 2 times -1 is -2 plus 1 minus 3 equals -1 minus 3 is going to equal 1 minus 3, which is going to equal -2. So we got, what did we plug in? -1, -2. Ooh, okay, so that wasn't the vertex. All right, to save us some time, let me go ahead and tell you kind of how to find the vertex. The vertex is going to be the spot where this absolute value piece is 0. Okay? Ooh, and this is going to be kind of a nasty one. I should have thought of this before I made it. But maybe we can step around this. But this vertex is going to happen whenever this is at 0. So if I plug in a -1/2, 2 times -1/2 is -1. So I tell you never to graph these, but if I do that, -1/2 times 2 is -1. -1 plus 1 is 0. 0 minus 3 is -3. So it's at -1/2, -3, right there. So I have a feeling when I do x equals 0, it's going to give me the dot on this side, and they'll start counting back up. So this weird half one is where the vertex is at. So let's try 0. We might can do it in our head. Plug a 0 in. 2 times 0 is 0. 0 plus 1 is 1. 1 minus 3 is -2. Oh yeah, and you'll see 0, -2. Now you'll start to see these y values kind of repeating themselves. 2, 0, -2. I bet I'm going to get -2, 0, 2. So if we put a 1 in there, 2 times 1 is 2. 2 plus 1 is 3. 3 minus 3 is 0. So 1, 0. And I bet if I plug a 2 in, I'm going to get 2. Let's look at it. 2 times 2 is 4. 4 plus 1 is 5. Absolute value, that's 5. 5 minus 3 is 2. Oh, yeah. So, what was it? 2, 2. So I can see my V shape even if I wouldn't have done. Let's pretend I did not do the half point there. We'd say, oh my, it must be somewhere in there. I think we could complete it. But the best way to do these is to know where this turnaround is. I picked maybe a bad example, having it be a half, so that's my fault. I should have thought about that before I did it. I'm just sometimes I teach so many different classes, I forget kind of what level I'm teaching to and what I want to cover for the day. So there we go. But that's that one. I'll try to make sure I don't give anything quite so nasty. Well, that's not too nasty. Maybe it's not bad. Maybe I should hold you to that standard. But it's much easier if this is not a fraction. So anyways, that's all I have for you today. And those are the parent functions. Absolute value parent function, square root parent function, and an x to the third parent function. So those are things you may want to kind of memorize. But notice that no matter what style of graphing you have, this table of values thing seems to be good because it works for almost every situation. Now you may have to try a lot of numbers, but that's okay. You're the one picking the x's. Just trying to maybe think ahead and pick smart x's. Or if you pick a bad one, just scratch it out and say, I'm not using that one. That one's stupid. I'm going to pick ones that I think are good. Okay? Anyways, have a nice day. I'll see you next time.